Hey everybody, and welcome back to Front-End Expert. In this video, we'll be going over the basics of JavaScript, which is the primary programming language of the web. More specifically, it is a multi-paradigm general-purpose language with dynamic typing. Now that's a lot of jargon, but don't worry too much, we will break all of this down throughout this video and the rest of the crash course. First, JavaScript is what we call a multi-paradigm language. Programming paradigms are simply styles of programming. Many languages are built to support specific paradigms, but JavaScript is extremely flexible and supports a variety of paradigms, so we call it multi-paradigm. This means the language isn't very opinionated about how code is structured, and there's oftentimes multiple solutions to the same problem. First, JavaScript is known as an event-driven language. This is arguably the most unique feature to JavaScript. We'll see more throughout the crash course, but essentially this just means that our code will run in response to events, such as a user clicking on an element. JavaScript also supports functional programming, which is a paradigm based on writing pure functions, which are functions that will always have the same result for a given set of arguments. So if you give them the same argument, you will get the same result, and you also shouldn't have any side effects to a pure function. One of the key characteristics of a functional language is that it uses first-class functions. This means that functions can be treated as values just like any other value. For example, we can assign a function to a variable or pass it as an argument to another function. On the same note, JavaScript also supports higher-order functions, so our functions will also be able to return other functions. Again, we will see this throughout the crash course. On the other hand, JavaScript also supports object-oriented programming. Nearly every non-primitive value in JavaScript is an object, which are just stores of data, and we can create custom objects and even have them inherit from each other. Finally, JavaScript supports both imperative and declarative programming. Imperative programming is simply when we specify the logic and control flow of a program to achieve our desired output. This means JavaScript supports all of the major control flow statements, such as if and else blocks, switch statements, for loops, while loops, and so on. On the other hand, JavaScript supports declarative programming. The idea here is that we write code detailing the output we want rather than the control flow. This is usually closely tied to the idea of functional programming. For example, instead of using a for loop to describe the control flow and loop over an array, instead we can use the for each function of that array to loop over it, which will abstract away some of the details of how that control flow is happening. Okay, so now one key point about JavaScript is that it is constantly evolving. There's a standardized version known as ECMAScript that almost all major browsers adhere to, and this gets new updates pretty frequently, usually on a yearly basis. You'll oftentimes hear this referred to as ES and then a version number. For example, ES6 is a shorthand name for the version released in 2015. This version specifically was one of the largest updates ever, and it gave us many of the modern features we use in the language today. So oftentimes you'll hear ES6 used as a name to just mean modern JavaScript, but it is really an ECMAScript version. Next, I want to briefly explore how JavaScript is executed. You might hear that JavaScript is an interpreted language, meaning that our code doesn't get compiled into any machine code. For the most part, this is accurate, but there is a bit of nuance here. JavaScript is run in a program known as the JavaScript engine. Browsers are free to implement the engine pretty much however they want, and some do interpret the language. However, most modern browsers are now using what we call just-in-time compilation instead. This is very similar, but essentially it means the browser converts the code into binaries while it is running it, which can result in some better performance. We'll discuss more details of the engine when we get to the video on the event loop, but the important point here is just that it is a program in the browser that can execute JavaScript code. Now finally, let's discuss the dynamic typing aspect of JavaScript. So in JavaScript, we don't declare types. However, there are a variety of different types used internally, and it can be useful to know what they are. So the primitive types in JavaScript are numbers, big ints, booleans, strings, symbols, null, and undefined. So first we have numbers, which are pretty self-explanatory. The one key difference here from other languages you might have used is that there's no distinction between integers and floats or doubles. They are all just under the same number primitive. Next, we have big int, which are the most recent addition to JavaScript in just 2020. These don't tend to get a ton of usage, but their purpose is to hold numbers too big to store in a number primitive. Specifically, numbers max at 2 to the power of 53 minus 1, which is a huge number. But if you need something bigger, you can declare a big int by wrapping it in the big int function call, or adding the letter n to the end of the number. Next, we have booleans, which are the true and false values. The one key point here is that the keywords are in lowercase, which can be different than some other languages. We also have strings, which again work just like most other languages. We can use single or double quotes, there isn't really a difference between them, it just comes down to personal preference and making sure you're being consistent. Next we have symbols, which were actually a fairly recent addition to the JavaScript language in the ES6 specification. The purpose of symbols is to represent unique values, so wherever we call the symbol function, we get a new unique value, even if we use the same description string. And we will see more about symbols throughout the crash course as well, specifically in the video on objects, which is where symbols are most commonly used. Finally, we have null and undefined. This is a bit different because most languages don't differentiate between these values. The key difference is that null must be assigned. We have to explicitly set a variable to be null if we want it to be null, and essentially it just means that it has no value. Undefined, on the other hand, means the value has not been set at all. So if we don't initialize a variable, it will be undefined by default. Okay, so with all that said, let's move over to the code editor and do a quick demo. Okay, so now we're here in the code editor, and let's look at a quick demo of JavaScript. So first, let's create a variable. To create a variable, we usually use the let keyword, and then we can give it a name. So for example, I can say let num, set this equal to 10. Now this might look a little bit different if you're coming from a different language. For example, if you're coming from Python, you might notice that we have a semicolon at the end of this line. And the semicolon is simply how we denote the end of the line. Technically, the semicolon is optional because of something known as automatic semicolon insertion, where JavaScript will just add the semicolons in for you if you don't include them. However, we do usually recommend to just include them anyways. This tends to be the style that most of the large companies in industry are using, and it can prevent some very specific strange bugs. Most of the time you'll never run into those bugs if you omit the semicolons, but it's usually just safer to include them. And then you also will notice that we use the let keyword, but we don't specify a type. So remember, JavaScript has dynamic typing, so we don't need to do something like, say, integer or number here, like we might do in another language. Instead, we simply say let to declare a variable. And then we can print out this value. So to do this, we can say console.log. So console.log is a function we have access to, and this function takes in a value and can print it out. So for example, I can console.log the number, run this code, and you can see in the output we logged out 10. We can also change the number. So for example, I could say num and set this equal to 20 now. So when we reassign the value, we don't use the let keyword again. So let is creating the variable, but when we are just reassigning it, we don't need to create a new variable. So therefore we don't use the let keyword here. And then we could say console.log of num again. And in the second log, we will log out 20 because we changed the number to be 20. Now there is another keyword we can use here, and that is going to be const. So const defines a constant. It works just like let, but the difference is we can't reassign the value. So if I run this code, we actually get an error. It says assignment to a constant variable, because on line 5, we tried to change num, but we can't change a constant. And you'll see we actually did log out 10 before this. So it runs this code, and then when it gets to this line, it throws an error because of the fact that we tried to assign to the constant variable. Okay, so we will go more in depth on const, let, as well as there's a var keyword that is a bit of an older version of let in the video on assigning variables. But for now, let's remove this code. And I want to, instead of having our number just be a number like 10, I want to make it a decimal. So let's say let num, and we can set this equal to, let's say 10.8. And then we could say console.log out the num. So remember again, with JavaScript, we don't distinguish between doubles or floats and integers. They are all just numbers. So this num is of the same type as the number we had before. And just like other languages, we do have some useful functions we can do on numbers. So I'm going to remove this num from the console log. And first what I want to show is math.floor. So essentially, this is just going to take in a number and it is going to round it down. So when I log this out, we get 10 because 10.8 rounded down is going to be 10. However, we can also do math.round, and this is simply going to round by the traditional measure of rounding up if it is above 0.5 and rounding down if it is below 0.5. So if I run this code, we get 11 because 10.8 was closer to 11 than 10. However, if I made this 10.4, we would get 10. And also if I made it 10.5, we get 11. So if you are right at the middle, it does round up. Now, math also has one other interesting function that is random. So this is going to return a random number between 0 and 1. So if I run this, you see I get this random long decimal, and we can keep running it, and we will keep getting more values between 0 and 1. So this can be useful occasionally in algorithm-style problems where you need a random number. Now, another useful set of functions related to numbers is going to be when we have a string representation of a number. So let's say let strnum, and I will set this equal to the string of 10.8. So this is a string rather than a number. And if we want to convert this to a number, what we can do is we can call the number function. So this is actually a constructor that makes a wrapper object around the number, but it gets treated in JavaScript essentially the exact same as a standard number. And we can simply say string num, and when I run this code, we get 10.8 once again. And similar to this number function, we also have one more function. So we can say console.log of parse int, and we can parse an integer of string num. So what this is going to do is it's going to take the string and look from left to right, and it's going to go until it finds a character that is not part of an integer, and that is going to be the number it parses. So now we get 10 for the parse int, and the number is 10.8. And parseInt can be particularly useful if you have a value like 10 pixels. This probably came back from CSS, and we might need to parse this as just 10. So if I run this code, number is going to give us this value NaN, which means not a number. So it looked at this string and it said this has characters that are not numbers, so it just returns not a number. On the other hand, parseInt parses this, so it goes from left to right until it sees something that isn't a number, which in this case it saw the P character. So once it got to the pixels, it said, okay, I'm done, and it returned to us the number 10. Now there's also parse float. So parse float is going to work the same way, but it's not going to restrict us to integers. So for example, if this was say 10.8 and I run this, we would parse the float of 10.8. However, if this had been parse int, then we would get just 10. Okay, so let's remove this string number now. And next, what I want to look at is how we can take this number and we can do some basic operations on it. So we can say console.log number, and then we have all of the standard operators that we have in most languages. So for example, I could say number plus, and let's add 10 to it. And when I log this out, we get 20.5. And then of course we have subtraction, addition, and multiplication as well. And we also have the modulo operator. So I could say num mod 10, and this is going to be the remainder. So we do 10.5 divided by 10, and then we get the remainder of that, which happens to be 0.5. And we can also do comparison here. So I could say number is less than 10. This is going to be false. I could say number is greater than 10. This is going to be true. I could set this equal to 10. This is going to be false as well. So with equality, we use 3 equal signs most of the time, but there's a loose equality, as we call it, with 2 equal signs. This is also going to be false. And we will go more in depth in the crash course on the differences between these, but essentially 2 equal signs is only going to compare the values, whereas 3 equal signs is also going to compare the type. So for example, if I had changed num to be the string of 10, then this is going to be true with the string 10 double equal 10, but with strict equality, so 3 equal signs, this is going to be false. Okay, but I will go back to num, and we also have less than or equal to. So we can say, is number less than or equal to 10? It is not. But if this was 10.5, it would be true because the number is less than or equal to 10.5. And of course, we also have greater than or equal to as well. And this works exactly how you would expect. In this case, it is still true because we are still equal to 10.5. And if I change this back to 10, we still get true. But if I change this to 10.6, we get false because num is no longer greater than the value on the right-hand side of this operator. We can also use exponents in JavaScript. So the way we do this is with a function. So I could say math.pow, and maybe I want 2 raised to the third power, and you can see we get 8. So this is 2 cubed. And additionally, like we saw, if we try to do any operations that don't result in a number, we get that not a number value. So if I did number and I tried to multiply by the string of a, we would get this not a number value, which simply says that we tried to do some math operation and we didn't get an actual number back. There was nothing reasonable that it could return, so it returns not a number. We also have keywords we can use for infinity as well as negative infinity. So I could say console.log of infinity, and this is going to give us just infinity back. We can also add a negative sign before this and we get negative infinity. We don't tend to use this too often, but if you ever need a number that is greater than all of the other numbers or less than all of the other numbers, then infinity and negative infinity can be useful occasionally. And next, let's take a look at big int. So to create a big int, we usually use the wrapper function. So we can call big int on a number. So for example, 100, and we get the big int of 100, and you can see it has that letter n at the end of it. We can also declare this by simply saying 100n, and this is going to work the same way. And this will roughly be treated the same as 100, it just allows us to go to those super large numbers. And it also has a different type. So there's a type of operator we can use to check the type of a value. And if I do type of 100n, we get big int, whereas if I do type of just 100, we get a number. But for the most part, these will end up working the same way. And we usually just use number unless there's a specific reason not to, and you need a big int because you are going to have some massively large number. Okay, so now let's move on from numbers, and I want to look at strings. So let's create a string, and I'll call it ABCD. And then we can simply say console.log of our string. This will work just like console logging out a number, and we get ABCD in the output. We can also use concatenation with a string. So for example, I could say plus EFG, and when I log this out, we get ABCDEFG. Additionally, if we use the plus operator with a number, so for example, the string plus the number 10, it is still going to do concatenation. So it's going to convert whatever the other value is into a string, and then it is going to concatenate them together. Strings can also use the comparison operators. So for example, I could say this string is less than EFG, and we would get true because ABCD is less than EFG alphabetically. But for example, if I said greater than, we would get false because the string on the left is less than the string on the right alphabetically. And of course, we can always compare these with the equality operator. So this is going to be false because these strings have different values. But if I made the string have the same value, we would get true. So a key point here is that strings in JavaScript are primitives, so this comparison is happening based on their values. This is different from some other languages where strings are treated as objects and need methods to check value equality. Additionally, if I change this string instead of using single quotes to use double quotes, these strings are still going to be equal to each other, so we still get true. And the reason for this is that single quotes and double quotes are essentially the same thing. There is no difference, so they are still the same value of ABCD. It doesn't make a difference which one you use, but you do want to be consistent just so your code looks nice and clean. Additionally, we can use escape characters if we need to add a special character inside of the string, specifically if we need the quote character inside of a string. So for example, what if I had the string, hello, this is a single quote, and then I wanted to include the single quote. If I try to include it like this, we're just going to get a syntax error because it thinks that this first single quote was the end of the string, and then there's just this floating quote outside of it. So what we do is we add the backslash, and then this escapes the character after it. So now this character of the single quote is going to be included as part of the string rather than being evaluated as closing the end of the string. And now we get, hello, this is a single quote, and then we have this single quote character. We can also use this if we need multiple lines. So for example, I could say, hello, and then we can do \n, which is the new line character, and then I could say world, and we don't actually need the space here, and then we would get hello world, but we get the string on 2 different lines. So the \n is going to be evaluated as being a new line character. There is also one other way to define a string with multiple lines, and that is to use backticks instead of the single quote or double quote. So if I get rid of this string, and I make a string with backticks, then we can go to new lines inside of this string. This is known as a template literal. So for example, I could say hello, and then I could go to a new line and I could say world. and this string would work, but you do want to know that it is going to account for everything in the string. So for example, if I had hello on a new line like this, then we have moved our result down because we actually have this new line right here as well. So right after the quote, we have a new line character. So that is part of the string. So you do want to be careful with doing that with template literals, but it can be a nice syntax if you have a string with a lot of new lines in it. Template literals also allow us to have values inside of them. So for example, I could say result, and then after this, we can do a $sign and then curly braces. And inside of the curly braces, JavaScript will just evaluate whatever we put here. So for example, I could say 10 plus 20, and we get result is 30, and this is all going to be one big string. Okay, so next, what I want to show is what would happen if we had a string that was super long. So let's say this is a very long string. And maybe we want to break this up into two different lines. So we want to have this string on 2 lines of code, but we want the string to be 1 line in the actual output. And there's 2 main ways we can do this. So first, we could break this into 2 strings. So I'm going to add quotes on either side, and then we could concatenate them together. And I could just go to a new line like this. We usually tab it over, and this would work perfectly fine. So now we get this is a very long string, and we will need to make sure we include the space character here as well. So now we get this is a very long string, and it is properly spaced out. We could also put the plus at the end of the line rather than on the next line. So like this, and this will work the same way. It's just up to you which style you prefer. This tends to be the more common style to have the plus at the end of the line, but either works, they are the same thing. Now there is one more syntax to do this that is a little bit less common, but it does work. And what we can do is rather than having 2 strings, we can make this one big string. And at the end of the first line, we're going to put a backslash. And this just says that this string continues on to the next line. And now if I run this code, we get this is a very long string. However, it did include all of this space, so we can't tab it over if we do that, because this becomes part of the string. So I'd have to move this all the way back over to the left without any indentation, and now we get this is a very long string, as you would expect. Okay, so now let's remove this string, and what I want to show now is how we can work with the string that we have to get different characters and call some different functions, just like you might do in other languages. So first, if we want to get a character, we can use array syntax. So I could say string at 1, and this is going to give us b, because the first character, so the first one is the 0th character, so the first character is b, so this gave us b. We can also call a function for this, so I could say string.char at, so character at, and then I could say 1, and we get b here as well. Okay, so now let's look at a few more of these functions. So for example, I could say string.includes, and includes is just going to look through the string to see if it finds the value. So for example, string.includes of b is going to be true, however, e is going to be false because the letter e is not in the string. We also have a function that is starts with, so this is going to check if the string starts with a value, so e is going to be false, a would be true, b would also be false because b is not the first value in the string. And similarly, we also have ends with, so ends with is going to check if the string ends with a value, so b is still false, but d would be true, and of course, e would be false as well because e is not even in the string. We can also call string.to uppercase, and this is going to convert the string to all uppercase. So now we have ABCD in all uppercase. And additionally, there is a .to lowercase function. So for example, this is going to convert the string to uppercase, and then we are returning that string and converting it back to lowercase. So now we have ABCD in all lowercase once again. Okay, and we also have the substring function. So there's a few different ways to get a substring. The more common one you tend to use is substr, so substr. And this is going to take in the starting index, so for example 1, and then the number of values you want to get, so let's say 2. And then we can close out this function call, and when I run this code, we will get bc. So we started at index 1, which was b, and we got 2 values, so we got b and c. Additionally, if I only include one value, it's just going to be the start, so if I do substring of 1, we're going to get bcd because it just started at index 1 and it went to the end of the string. Now similarly, we have a slice function. So slice, if we only have one value, will actually work the same way, so we still get BCD. However, if we include another value, rather than being a count, it's going to be the ending index. So for example, 1, 2 is just going to get B, because it got from the index 1 to the index 2, but the second index is exclusive, so it just got the letter B. But for example, 1, 3 would get BC, and 1, 4 would get BCD. 1, 5 would also get BCD, so if you go out of bounds, it is just going to go to the end of the string. And it's worth noting that none of these functions actually change the string. So if I do console.log of str, then we still get the same string, so we still have ABCD here. So all of these functions are not in place. They're returning new strings rather than editing the original one. But let's get rid of this console log for now. Okay, so next what we have is this function pad start. And what pad start does is it takes in a count, so how large you want the string to be. So for example, I want this string to have 10 characters. And if it's not 10 characters, we give it some value to pad the start with. So for example, the dash. And now what I get is we get 6 dashes and then ABCD. That way it creates a 10 character long string. However, if this number was smaller than the size of the string, so for example 3, we don't get any dashes added, so this is a minimum size, and in this case, because this string had a length of 4 and the minimum size was 3, we added no dashes. Same thing with 4, we are still already at the minimum size, but if this was 5, we would get 1 dash to make it 5 characters long. And there's also pad end, so this works the same way, except it adds the characters to the end rather than the beginning. We also have a function that is trim. So for example, if this string had a bunch of spaces at the beginning and I call string.trim, it is going to remove all of the white space on either side and we get just ABCD without all of those spaces. There's also trim start, so this would only trim the left-hand side. And there's also trim end, which only trims the right-hand side. So in this case, all of the extra spaces were on the left-hand side, so this didn't actually do anything. And finally, we have a split function. So for example, if I had A, B, C, D with commas in between them, we could call string.split and then we pass in the delimiter. So for example, the comma, and now you'll see we get the array with the values A, B, C, D. However, if we split on something that wasn't in the string, say the letter E, then we end up just getting an array with the entire string in it. Okay, so now let's move on from the string. And what I want to look at next is going to be objects. So we can create an object. So let's say, make this a constant. We can call it a person. And we use the object literal syntax, which is going to be curly braces. And these are key value pairs. The keys are going to be strings, and the values can be pretty much whatever we want. The keys can also be symbols, but we will see that in a later video. So for now, we will make them strings, and we don't actually need to include the quotes here. So for example, I could say name. I will set this to be Connor, and then we use a comma, and maybe we have a course, and this is going to be front-end expert. You might also see a trailing comma here sometimes. So JavaScript does allow you to add a comma at the end, even though there's not another value. And a lot of people do prefer this. A lot of style guides enforce that there is a trailing comma. The reason being, when we need to add another item to this object, you wouldn't need to edit the item before. You don't have to worry about the commas because every line has a comma. So every line is sort of following the same format. Okay, so let's add a semicolon here and we can log out the person. So I can say console.log of person. And you can see in the console, we get the object with the name of Connor and the course of front-end expert. And these objects can also be converted into JSON, so JavaScript object notation that we can use for sending data back and forth to the server or to use with other languages. So for example, I could say json.stringify and we pass in the person. So this will turn our entire person object into a string. So if I did the type of operator here, you would see we now have a string representation of the object rather than the actual object. We can also convert this back into an object with json.parse. So we can parse a string as an object, and now we get the original object back because all we did was convert it to a string and then convert it back into an object. And we can see this with the type of operator as well. So now we have a type of object. And of course, we can get values out of the object. So we could say person.name to get the name from this object. We get Connor. We could also change values. So I could say person.name, and I could change this to Clement, for example. And now when I log out person.name, we get Clement. And it's worth noting that even though we did a constant, we are still able to change the values inside of the object. We just can't reassign the object itself. Now, there are also a variety of pre-made objects that we can use. So for example, we can create a map. So I could say const map, and I can set this equal to a new map. So when we use these pre-built classes, we use the new keyword and their constructor function to create that object. And a map works very similar to a standard object, the difference being that map has some functions for getting and setting values, as well as the keys in a map can be of any type rather than being restricted to strings and symbols. So for example, I could say map.set of 1, 2, 3, and I could give this a value of hello. And then I could say console.log of map.get, and we can pass in the key. So the key is 1, 2, 3, and you can see that now we end up logging out hello. These keys are also unique. So if I added another map.set of say 1, 2, 3 and made this one be world, then what's going to happen is we actually just override the value. So now 1, 2, 3 is set to world. So we log out world, and this hello value has been lost. We could, of course, change this to be maybe 4, 5, 6 here. And now 1, 2, 3 would log out world, but we also have 4, 5, 6 inside of the map. So this would be hello. And we can get the total size of the map using map.size. So this would be 2 because we've added 2 items to the map. Additionally, if I do map.get of something that's not in the object, so there is no key for whatever we pass into map.get, so say map.get of 0, it is going to return undefined. So this doesn't throw an error or anything like that. It simply returns undefined. Now, similar to maps, we also have sets. So I could say const set equals a new set, and a set works just like a map, except there aren't key value pairs. There's just the values, and the values will be unique. So for example, I could say set.add, and I could add in hello. And then we could also maybe say set.add of world. And then we could say console.log of our set. And you would see we have a set with hello and world inside of it. We can also do console.log of set.has and then some values. So say hello, and this is going to check if the value is inside of the set. So this is going to be true because the set does have the value hello. But if I did hello world, this is going to be false because it has the values hello and world, but it doesn't have this all as one string. And of course, set also has a size. So the size of this set is currently 2 because we have added 2 values to the set. And again, these are unique. So if I did set.add of hello again, this isn't going to make a difference because of the fact that hello was already in the set. We can also remove values. So I could say set.delete, and maybe I want to delete hello. So now we no longer have hello in the set. So the size printed out to be 1, as well as if we did set.has hello, we would get false because hello is no longer in the set. But of course, set.has of world would still be true. And for the most part, all of these functions tend to be shared between set and map. There are a few different keywords for one or the other, but most of them are very similar, which makes them very easy to use, which is nice. But at the same time, we don't really need to use these. A lot of the time, you will see that we just use objects as well as arrays for most of what we do in JavaScript, but there can be times when a set or a map is useful. For example, if you need keys that are not strings, then a map can be useful for that. So with that, let's take a look at arrays. So I will create an array with const array and set this equal to 1, 2, 3. This creates a list of the values 1, 2, and 3. And I could say console.log out the array. And now we get 1, 2, 3 as an array. We also have array.length, which is going to get the size of the array. We can also get an individual value with the bracket syntax. So for example, array at 1 is going to be 2 because it is 0 based. So this is index 0 and index 1 is here where the 2 is. And we can also add to the array with the push function. So I could say array.push, and I want to push, let's say, the value of 4. And then we could print out the array and we get 1, 2, 3, and 4. It's also worth noting that arrays are just objects under the hood. So if I do type of the array, we are actually going to get object. So arrays are simply an object that have some special syntax for them, but they are just objects. Okay, so now let's remove this code as well, and I want to take a look at functions. So to define a function, we use the function keyword, and then we give it a name. So for example, I can say add to, and this will take in a number, and let's just have the function return the number plus 2. So if you're coming from another language, this probably looks pretty familiar. It is very similar to what we might use in other languages. We use the curly braces to denote what is inside of the function. We use the function keyword to create the function, and then we can add parameters inside of these parentheses. And of course, we can use the return keyword to describe what the function is going to return. So now I could say console.log of add2, and we can pass in 3, and then we're going to get 5. So 3 plus 2 gave us 5. We can also give a default value to the parameter, so we can use an equal sign here and say I make the default value to be 6. So now we are still going to get 5 because we have passed in 3. But if I don't pass in a value, we get 8 because num was undefined. So in that case, it used 6 instead. So we did 6 plus 2, and we got 8. And again, we do have first-class functions in JavaScript, so we can sort of pass them around as values and use them like any other value. So for example, let's create a function, and this function is going to be called callfunc. So it's going to take in another function as a parameter and a parameter to give it. And then all it's going to do is it is going to console.log out a call to func with the parameter. Okay, so now what we can do is we can remove this console log and we can call callfunc, and then inside of callfunc, we are going to pass the add2 function. So we're not calling add2, we are passing it by its name, like a standard variable. And then we can pass in a parameter. So maybe I want 10. And now if I run this code, we log out 12, because we passed add2 as func, and we passed 10 as the parameter. So we logged out a call to add2 because func was add2 with 10 as the parameter, so then we did 10 plus 2 and we got 12. And again, we will see more about this throughout the crash course, but just to know that functions can be passed around as standard values just like anything else. And functions themselves are actually objects. If we use the type of operator here, this is special cased a bit, so if I do type of the add2 function, for example, we're actually going to get function, but they are objects. The type of operator is special cased to where if the object is of type function, it says function, but function itself is not a type. We know this wasn't one of our primitives, so functions themselves are actually objects. We can see this as well by saying add2 and then checking if this is an instance of an object, so the object class, and it does turn out that add2 is an instance of an object. Okay, so next, let's remove this function code, and what I want to look at now is looping. So we can create a for loop just by saying for, and then we declare a variable. So for example, let I equal 0, and then we have a condition for when we continue looping. So let's say I is less than 4, and then we can say I++. So this will happen at the end of each iteration. And now we define the inside of the loop using curly braces to create a block, and we could say console.log of I, and now we get 0, 1, 2, and 3 logged out to the console. Now there's also two special keywords we can use here. So first of all, we could say if I is equal to, let's say 1, then what I want to do is I want to break. So break is just going to break out of the loop. So now what we get is just 0 and 1. So we log out 0, then we check if 0 is equal to 1. It's not, so we continue. Then we log out 1. We check if 1 is equal to 1. It is, so we hit this break statement. And in the break statement, we end the for loop, so we never end up logging out the rest of the values. We can also move this to the beginning of the for loop, and instead of break, we can say continue. And continue is not going to stop the loop, but it is going to skip an iteration. So now we get 0, 2, and 3. So on the iteration where I was 1, we called continue, and we never hit the console log statement, so we just moved on to the next iteration. Additionally, we also have while loops, so I will remove this, and we could say let I equal 0, and we could do while I is less than 4. Then we could console.log out I, and then we can say I++ at the end of this loop, and we get the same values we had before. So this is roughly going to work the same way as that for loop we had, and we end up getting 0, 1, 2, 3. There's a little bit of a difference here in that the I variable is scoped a little bit higher in this case, so it is scoped outside of the block versus inside of the block, but for the most part these are the same. There's also a do while loop, so we can say do, and then we put the block here, so I can remove this code, and we can push this inside of the do block, and then we end the block with the while statement. And this will do the same thing as before, but it's going to run the code inside of the do block before it checks the condition. So right now this is the exact same. But for example, if we had I is less than 0, this is never true. However, when I run this code, we still log out 0 one time. The reason being that we ran this block of code one time before we ever checked the condition here. So we check the condition after running the code rather than before running the code. There's also a few other types of loops in JavaScript, so I can remove this code, and we can do for, and this is going to be a for of loop. So we define a value, so we can say const value, and we say of, and then an iterable, so for example an array, so I could say 1, 2, and 3. And then we have a standard for loop, where value is going to be the value of that iterable. So for example, console.log of value, and this is going to give us 1, 2, and 3. This also works with strings, so strings are iterables, so I could have the string ABC, and we log out A, B, and C. So it is going to iterate through each character of the string, almost as if it was an array. Additionally, if I had an object, so if I said const obj, and set this equal to an object literal, and we can have the same object we had before, so let's say name as Connor, and then we can say course is front-end expert. Then what we can do is we can say for, and we'll do const key, but instead of, this is going to be in. So it's going to get every key in the object, and we can say obj, and then we can simply do console.log of key. And this will end up logging out the different keys. We could also get the values, so we could do obj at key, so we can use this bracket syntax if we have a variable that we're trying to get out of the object, and we end up logging out Connor and front-end expert. Console.log can also take two values, so I could do key, comma, and then the object at key, and we would log out name Connor, and then course front-end expert. So console.log is able to take in comma-separated values as well as a single value, so in this case we log out all of the keys and the values from the object. Now there is a bit of nuance as to which keys are actually included here, but we will see more about that in the video on objects. For now, just know that for the most part, this will go through all of the keys that we have added to the object. And now finally, we can also get an array, and we can call a function on that array. So we could do 1, 2, and 3, and then the array has a for each function. So for each is going to work like a for each loop, but this is a bit more of a functional way to do this. So it's a bit more declarative in that we aren't describing the exact implementation of the loop. We are just going to say what we want to happen in each iteration. So we can say for each, and we pass in a function here, and this function will take in a value. So for example, we can get the value like this, and simply say console.log of the value. And this is going to log out 1, 2, and 3. And now this is sort of mixing a few different concepts. So first of all, we have this function that we have passed in as a parameter. So we are using the concept of these first-class functions, where we can pass functions around. Additionally, this is known as an anonymous function, so we didn't give this function a name, the reason being that we never have to call it by name, so we don't need to actually give it a name, we can just use this anonymous function syntax. And there are a few other ways to define these anonymous functions, but again, we will see all of that and more throughout the crash course. There's also a bunch more iterating functions of the array object, but again, we will see all of that later on. Okay, so now let's take a look at conditionals. So we can have a Boolean, so let's say const condition, and I will set this condition to be equal to true. And then we can use an if check to decide if we want to run some code based on the condition. So for example, I can say if condition, and in the case that the condition was true, then I want to run some code. So I can say console.log it was true. But then we can also add an else block. So in the else block, I will say console.log it was false. And now we can run this code and we get it was true. And if I made this to be false, we would get it was false. We would also end up falling into the else block if we set this equal to null, because all we checked was if condition. Null is considered a falsy value, so when we use it as a condition of an if statement, it will act the same as false, and thus we fall into the else block. But we could also use an else if, so I could say else if condition is strictly equal to false. And then if we wanted, we could also have an else block, so I could say console.log default. So now we end up logging out default because of the null value. If I made this true, we would end up logging out it was true. And if I made this false, we would log out it was false. Okay, so now we also have switch statements. So I could say mynum, and I will set this equal to, let's say, 2. And then what we can do is we can say switch and mynum. And I'll add a space here as well. And then we can add the curly braces. And inside of these curly braces, we add case statements. So let's say in the case that mynum was set equal to 1, then what we're going to do is say console.log it was 1. And then we can also maybe do a case of 2, and we can console.log it was 2. And then let's add a default case. So I could say default, and inside of the default case, we will console.log default. Now what's interesting here though is it's not going to stop when it hits one of these cases. So when I run this code, we get it was 2 and default. So default will always run regardless. So case 2 ran and default ran. But what we could do instead is we could add a break statement inside of these. So I will add a break at the end of each case, and now we only get it was 2. So almost always with switch statements, you will want a break at the end of each case, or potentially a return value, but most of the time you don't want to allow it to just keep moving through the switched cases. We could also have multiple cases here, so I could do case 3 as well, and now it says if it is 2 or 3, log out it was 2. So if I made this be 3, we would still log out it was 2. Same thing if it's 2, but if I made it say 10, we go back to the default. And finally, we also have ternary operators. So I'm going to remove the switch case. So I can say console.log of mynum, and we're going to have a condition here. So we're going to say mynum is greater than 5. Then we have a question mark to start the ternary. And in the case that mynum was greater than 5, let's log out greater than 5. However, in the case it's not greater than 5, we use the colon, and I can say less than 5. And now you see we log out greater than 5. However, if I made this 4, we would log out less than 5. If I made them equal, so if it is equal, we would also log out less than 5 because mynum is greater than 5 is still returning false. So in the false case, we come over to the right side of the ternary operator. Okay, so now let's move on from conditionals. And what I want to show next is how we can do some error handling. So if we want to throw an error, we can simply say throw and then whatever we want the error to be. So I could say, oh no. And then if I run this code, you can see we get this error message. You also might see that a lot of the time we wrap this in a new error object. So I could say throw new error and then the string of oh no here. And now you can see we threw the new error of oh no, and it says error oh no. We can also catch these errors. So I can wrap this in a try catch block. So I can say try and move the throw inside of the try. So it's going to run this code, and in the case that it ran into an error, it will get into this catch block, and we can pass in the error here. And I could, for now, just say console.log out the error. And you'll see that we log out the error oh no, but it's not actually throwing the error. So for example, I could say console.log here, and now you can see we still end up logging out here. However, if we didn't catch the error, so if the error was down here, then we would not log out here. So we threw 2 errors here. The first one we caught, and the second one we did not catch. So we never got to the console log here at the end. Okay, but let's remove all of this code here. Once again, we can run this to get rid of the errors as well. And what I want to show now is commenting. So there's 2 ways to comment in JavaScript. First, we have single line comments, which will use 2 forward slashes. So this is a single line comment. And we can use multi-line comments as well. So we'll do a forward slash and then the asterisk character. so the star, and I could have a multi-line comment. So I can go to new lines. We can keep going as far as we want until we have another asterisk and another forward slash, and then we are now outside of the comment. So I could say console.log of here, and this still works because we are no longer in the comment. But if I say moved the end of this after the console log here and ran this again, we don't log out anything because this is now part of the comment. Okay, so next I want to talk a little bit more about the console.log function that we've been using. So we can say console.log of, say, a value as a string, and we can log this out and we get value. But there are a few other options here. So we can also say console.error, and console.error is going to log out an error message. So I could say error message. And in this terminal here, it's actually going to display the exact same way, but in most browsers, it will display as a red message in the console. We also have console.debug, and console.debug will take in some debug message, and this will again display the same way here, but in the browsers, it will display differently. In some browsers, it doesn't even show these by default. You have to enable debug mode. So most of the time, we end up just using console.log, and then we might use console.error if we want to explicitly show an error message in the console. And then we tend to not use console.debug too often, but it can be useful. Next, we also have console.table, and this takes in some tabular data, as it calls it, which the easiest way to do this is with a 2D array. So for example, I can have an array with an array of 1 and 2, and then the next value will be an array of hello and world. And now it will print this out as a table. So we get this nice table in the console, which can be useful from time to time if you're debugging something with a 2D array. We also have console.count, and what count is going to do is it is going to log out a number, and each time we call console.count, we end up getting a higher number. So if I call console.count again, we get 2, but then I could do console.count reset, and this resets it back to the beginning. Add semicolons to these lines for good measure as well, and then we could say console.count one more time, and this time we end up logging out 1 again because we reset the count here. We can also pass in a label here, so I could say, let's just give it the string of key, and now these are different counts. So this one is the default count, however this one is the key count. So you can see key logged out 1, default logged out 1 as well, and then we reset the default. We could instead reset the key, and now the default wasn't reset, so this logged out 2, but if we say log out the key, we would get 1 because we reset that value. So this can be useful if you're trying to check to see how many times you got into a loop or how many times you called a function. You can add a console.count and then check in the console to see exactly how many times it ran. There's also a console.time, which is going to start a timer, and then I could do console.timeLog, and it is going to log out the timer. So this logged out 0.064 milliseconds because that's how long this took. But for example, if I added a for loop here, say let I is equal to 0, and say while I is less than a pretty large number, then we can say I++, and we won't do anything inside of this loop. You'll see now we get a bit of a larger number. If I add another 0 here, the number will get even longer. If I add another 0, it will take even longer, and so on and so forth. But timeLog doesn't end the timer, so if I copy this code, and then we come down here and run it again, we would get a larger number. The reason being that timeLog didn't end, so we continued counting from where we were. We could, however, do a time end here, and then now we are actually not going to log out anything here. We get a warning because there has not been a timer started, but we could do a console.time here, and now you can see we get a separate time, so these are now being counted completely separately. We could also, instead of doing it this way, add keys here, so I could give this a key, and we could even just do time log here of the key, and then we could do this one as just being the default, and now they are completely separate. However, if you are just using it once, you will usually want to end it, so I can say time end, as well as we could say time end down here to end both of the timers. It will do the same thing, but it will be a little bit less strenuous on the browser to not keep the timer running when we don't need it anymore. And finally, last I wanted to show that we have console.trace, and what this is going to do is it's going to log out where we are in the code. So if I run this code, you can see we get a trace to show exactly where we were. But if I put this inside of a function, so say function foo, and add the console trace inside of here, now you can see the console trace says we were in the foo function. Okay, so now the last thing I want to look at is what's called strict mode. So we can create strict mode by just adding this use strict string at the top of our file. This isn't a function or anything like that. It's just a string that we add to the top of the file. And all strict mode says is that the code should be executed in a slightly stricter manner. And this is useful because it's going to find some easy bugs for us. So for example, if I try to say x equals 5, this isn't going to work because we don't have a let keyword or const or var before x. So this is going to give us an error message. However, without strict mode, it would just work. And this can be a little bit confusing, so a lot of the time we will want to use strict mode instead. That way we are catching these errors. You can also use strict mode just at the function level, so I could say function foo, and inside of the function I can add use strict, and now just this function will be in strict mode. So I could say x equals 5 in here, and now if I try to call foo, we are going to get the error message even if I remove the use strict before it. So this is still going to give us the error message. However, if I remove this use strict, we don't get the error message. And what's interesting here though is, let's change this to say let x equal 5. And now outside of foo, if I say y is equal to 10, this is not going to give us an error message because of the fact that this code is not being run in strict mode, only this function is. Okay, so that's going to be the end of this video on JavaScript basics. We will go much more in depth on most of these concepts throughout the crash course, but I hope this gave you a good overview of the JavaScript language. And with that, that'll be the end of this video. I hope you enjoyed it, I hope you learned something new, and I'll see you in the next one.